Hello. Right, so today I'm going to solve a problem which is called reverse a sublist of a linked list. This question is in the book that I use. It's called Elements of Programming Interviews, and it's also like on LeetCode. So the question asks us to write. So let me start with an example so it's easy to go from there. So let's say that you have so that we have a linked list. Let's say that we have a linked list like this. And if the user, so the user need to provide us three things. First is the head. Second is the start of the nodes. So let's call that N. And the other one's like M. So what they want us to do is they want us to reverse this sublist, like this section. So our final answer should look like something like this. And also the question want us to move the pointer instead of modify the data, like changing the value in here. They want us to change the pointer. So they want us to preserve the value in the nodes. So what should we do? So we can break this problem into a smaller problem. Because let's focus on this three nodes, 2, 3, 4. So we have 2, 3, and 4. So the idea is we want to reverse the pointer to here and to here. As you can see, 4 is pointing to 3, 3 pointing to 2, and 2 is pointing to none. So we can think this problem as a big problem that containing this problem. But this problem is basically reverse all of the node in a linked list. So we're going to need a couple pointers in order to do this. Because we only have a reference to the head, which is 2, we need to have some sort of a reference. Go to here as well, and then from. So we have none right here too, but we only have reference to head. And the goal is we want it to be 2 and pointing to here. And change color. So I will just look at this code. We can have 2 pointers. One is called previous, and another one is called current. So we can do. So what we can do is let's write the code for here, and we also need a third pointer to remember this, because once we change this pointer, 2 dot next to point to none, we will lose a reference to 3. So we want to store 3 on this. And what's this? And also, so previous is equal to none, current is equal to 2, and then we want to change current dot next goes to none. and then we want to move previous to 2, current to 3, and then we do the same thing. So we want to do like current pointing to previous, and third is pointing to 4, and then do the same thing. Right here has become current 23. And we stop basically when we go like over n, like the number of times that we iterate like more than n, or m minus n basically. Yeah, but we need to think about the edge cases. Oh, we need to think about when we have like other nodes beside like those 3 nodes. Like what if it's they just want us like to, you know, reverse a sublist inside a linked list. So there's a lot of scenario right here. Let me repeat all this. Right, A, B. So I'm thinking of like we need to have some sort of pointer that know where this is. We also have a pointer that know where this is. And we have a function that allow us like to take this quotient and then convert this into D, C, and B. So we have like a specific function that allows us like to convert from this to this. And once we get that, and then that function also need to return let's call it start and end. So we can like find this easily. Restrict. It's also need to return this pointer as well. So let's call this before. Oh, let's call it after. And this is like before. So before and after is basically a place that we know that our reverse linked list will be put into. So our reverse linked list will be put into like in between A and A. So how would we run the code that's doing this? So like I mentioned earlier, we need to have at least like 3 pointers that's doing this. So let's write that function. So this function is the function that is responsible to do these portions, which is the reverse linked list. Let's go reverse and take start. So that's basically loop. So it's basically n minus n. So in the case that n is equal to 2 and m is equal to 5, you will get 3, so we want to go 3 times. Start loop. Right, that's basically it. So first we want to have like a pointer. So we start at previous is equal to none. And start. Top left. To start will eventually become n. That is equal to start. Right. So let's assume that our inputs are valid. So like in this case, we do while loop is not 0. So when loop is not 0, we want, and then we want to subtract loop. So first we want to remember the next one, which is thirds is equal to previous one currents or currents is equal to currents dot next. Right. So current dot next, it will store the third nodes. So it will store so like in the case that we have B, C, D. So initially we start with previous pointing to none, and then current is pointing to B, and third is pointing to here. And then we want to call currents dot next is equal to previous, and we want to update our previous to current. So current dot next now point to previous, and third is equal to current dot next. Current dot next is third. Previous now is current. And current right now is thirds. So current is right here as well. And then we loop again because according to our example here, m is 1, 2, 3, 4. So it's basically 4 minus 1. No, 4 minus 2. So it's 4 minus 2. So that would be 2. So right now our loop right here is initially it was 2. Now it was 1. So 1 is not 0, so it's still going here. And now loop is 0. And then you do the same thing. You do third is equal to current dot next. So third right now it's pointed to right here. And then current dot next is equal to previous. So this arrow is pointing back to B. And then previous is equal to current, so previous is right here. And then current is equal to 30. So current is right here. Okay. But is this what we want? I think we want one more iteration. Because we want to change, yeah, because like in the case that we have B, C, D, we want to change the pointer 3 times. So even though this is 4 and this is 2, even though there's like the difference like just 2, 1, 2, we want to change it 3 times. So I think what we want to do is do the one, yeah. So if that's the case, we will do like one more round. So third will be equal to current dot next. So current dot next would be B right here. Current dot next, just this pointer, is equal to previous, and previous is equal to D, and then current is equal to 8. Alright, so what we want to return is we want to return, I think we should return a list to let them know. So we want to return this point, and also this point. So we can do return. So let's just put them all of them in the list. So B would be, B would be start. This point would be previous, and then current. But there are some edge cases that we consider. I think I need to find a better name to name my nodes. It's all like kind of similar to each other. That's like one thing that I need to work on. So how do I figure this out? Like how do I call that function like in the main function? So let's say this is the main function. You have add, and you have n, and we want to call this reverse. But first we need to find this first. Find n. So we're gonna do like a. So first we need to check hat. If hat equal 9 or return hat. In the case that n is equal to m, we also want to return just hat in. So in the case that the user just you want to return this like reverse just one node, which doesn't really make sense. It doesn't really reverse anything at all if you just reverse yourself. So, or n is equal to n. Alright, now we need to figure out before n. So this will help if we have another node x like this. We need to go inside in order to know where is the node that we need to connect to a new reverse linked list. So in order to find that node is we need to have let's call it previous and current. Previous like none, and then current is basically just head. And in our case, let's say n is equal to 1. Let's create another counter count. So we create a while loop, while count is not the same as n. When count. Oh, this is n equal to. Yeah, according to the question, like especially at least like for LeetCode, they count the node like this is like node 1, node 2, node 3. So this is node 2. So increment is 1. So initially our count is 0. So right here, what we want to do is we want to move our previous pointer to point to A. So previous initially it pointed none. Now we want it to point to current. And then I think I should name this better. Let's call this before n, since it's a node before n. Should be n. And then for n nodes, we just n node. Just a hat, so this is a hat. All right. And then right here, you want, like I said, you want to change all the before node to end node. And then end node. Let's go to end node. Next. So in the case that n is equal to 2, also need to increment count. So in the case that n is equal to 2, for the first iterations, so right here, at A, B, C, this is equal to 2. And initially A is pointed to none. No. So Bn is pointed to none. So and node is pointed to here. So after like the first iteration, and node pointed to here, and B node pointed to here. I mean, since our node start at 1, I think our count should be 1. So now we have our B node and our end node. So this is the B node, and this is the node. So once we figure out like this B node, this end node, we can use our reverse function right there. So let's call that, let's call it 10 for now. So 10 is going to be the list of those. Going to be called reverse. And then start is basically just a node. And then loop, it's basically just n minus n. So this will give us the, I don't think we need to go back start, we just need to previous and currents. So previous basically the new beginning of the reverse linked list. So there's a lot of cases that could happen. What if there's no like B node, there's no before nodes, before end nodes, before end nodes. So in the case so if there's no before end nodes, so we have a lot of cases. Let me write it here. So let's say that we have like this input. No, yes. So let's say that these are like one, two, reverse like from here. If that's the case, if that's the case, we need to catch that. Basically, I always said. So previous here is basically you begin, and current would be the after node. So in the case that, so like this part, it's basically continue from here. So if, so in the case that we don't have any B nodes, because like if the input want us like to reverse the linked list like from here, the B node would be just none. So if Bn is equal to none, so in that case, let's say that they want to swap this. So this would be the after m, and this would be the previous, and so this would be the previous, and this would be the start. No, end node. This would be the end node. So what we want to do is we want to connect this to here, and we want to return this. So what we want to do is we want to do end nodes dot next is equal to current. So current is this one, which is temp. This would be temp 1, and then return. And we want to return this, which is previous. and this is just 10, 0. Or is the other case? What is the case that what is the case that after m is null? So let me draw some picture. Oh, you can use that picture. So let's double check here. Endnode.next. Can we guarantee that endnode.next is a nodes? Yes. Yeah, endnode.next has to be something, have to be valid. Because endnode is basically the node n. I mean, we assume that n and m is valid. And if, so in the case that, let's see, our after n, which is current, in the case that current is none. So like in the case that they want us to swap from this to this, our after m is would be none, right? So for that case, we just want so for that case, we would just, so we want to take this and point it to here. No. So reverse, so we want to, point it to here. And then let's just return hat. Now it's this way, it's the other way. So that it would be before n dot next pointed to previous. But since this is none, we don't need to do anything. We just return hat. How about the normal case? Is there a case that those two are none? Like in the case, okay. So in the case that they want us to reverse everything, so let's say A, B, C. So our before n and after m is all none, right? So what we want to do is we want to return this, and this would be the previous. But we want to check it like on top, right here. So we want to check because we want those two conditions to be true. We have a special condition. So if for n is equal to none, and after n is equal to none. In that case, we just want to return previous. the normal case is we want to, normal case we want to connect before n dot next with previous, and then n node dot next with current, and we return chat. Alright, seems like it works. Hopefully it works. Right, go and code it.